Hi everyone. So we're gonna need to make one more change to your assignment sheet. So if you will have that out. So changes you should have made yesterday. So on the 30th, we changed that to be 1.3C, which was a worksheet in Canvas. And there should be answers for you to go look at and see to see how well you did with your graphing. And if you need any extra help or anything like that, remember the tutoring center is now open. So it's after school in the libraries from 3 to 4. So just make sure you are taking advantage of that opportunity. It's Monday through Thursdays, or Monday through Thursday, in the library from 3 to 4. And there's a math teacher in there that will be covering each day, so you should be good. Okay, so on the assignment sheet, hopefully everybody's had a chance to get that out now. So again, yesterday we updated it to be 1.3C, which is a worksheet and the problems you got off of Canvas. Today we were supposed to do completing the square, but it really only made sense to do the completing the square worksheet if we were going to do 1.4, because 1.4 is graphing circles. And so it doesn't make much sense, since I already decided to move 1.4 to a different quarter. It didn't really make sense to keep doing completing the square at this point. So what does make more sense to do, and what we're going to change, is today is now going to be interval notation. This we are going to need in the very first section in our next chapter. So that makes more sense to put that there. So go ahead and cross it off down here. It will be a worksheet, but it will be due tomorrow. The interval notation concepts will now be on our test on Friday. So you do want to make sure that you are taking notes in class today, doing the assignment, checking your work, all that good stuff, to make sure you are understanding interval notation, because that we do need right away in our next section. Okay, so sorry for all the updates, but this is what your assignment sheet should look like now. And then we'll get started on your notes. So for the notes, for the first part of the notes, I'm going to ask you not to write anything. Just follow along with me. All the notes that I have typed up that I'm talking about, I will put in Canvas. After I get through my discussion and we talk about everything, then we will do some practice problems. And that part I will ask you to go ahead and write down. But the first part of the discussion, I might, we're just going to be talking, and so I might be talking too fast for you to write everything down. Unless you want to go back and watch the replay of the video in Canvas, you can definitely do that. But you don't have to feel like you're having to rush and scribble and get all these notes down really fast. That's not my intention for the first part. This first part is just to listen, absorb what I have to say. What I'm trying to explain to you, just follow along with me. Don't feel like you have to rush and write everything down. That's not my goal for the first part. I'll tell you when we get to the practice examples. So at that point, you're definitely going to want to write down some notes. All right, so for today, we're going to be talking about interval notation. But before we jump into that, I want to do just a quick review on what inequalities mean. So on here, I've written x is greater than 2. So basically that's saying x can be any number that is greater than 2. So it could even be something like 2.1, 2.2, 2.3, something like that. Anything greater than 2 would be included in our solution set, or whatever it is we're talking about. Versus x is greater than or equal to 2, that means 2 is actually included. So in that case, it could be 2 It could also be 2.1, 2.2, 2.3, anything greater than 2. So the only difference between these two solution sets is truly the number 2. So 2 is actually included here. The number 2 is not a solution in this first example. So just a quick refresher again on the greater than, less than, and then greater than or equal to or greater than or equal to symbols. All right, so keeping that in mind, interval notation is another way to write or represent some sort of inequality like this. So we're going to go through a few examples, and then like I said, these notes are in your Canvas page or in the Canvas module, so you don't have to hurriedly write down everything that's in these first few examples. But then we'll get to a point where I will ask you to make sure you're taking some notes, so you'll have those handy when it comes time to do your homework. So with interval notation, we have the idea that we're basically going to be using these symbols, parentheses or brackets, and we're going to use them to help us with the idea of our greater than, less than, greater than or equal to, less than or equal to symbols. So basically, we're going to use parentheses when we have a less than or a greater than symbol, basically saying they're not included. So like our example above, when 2 is not included in the solution set. We will be using brackets when we're trying to represent a less than or equal to or a greater than or equal to symbol. Therefore, meaning those numbers are included. So you'll get to see those in use in just this very next example. So example 1 says we have this inequality, this compound inequality. So we would read that as -3 less than x less than 3. Basically, that's saying that x is any real number between -3 and 3, but we're not actually including -3 and 3 in our list. So just like above, when we did not include 2 because we didn't have the equal to symbol. So in here, it could be any number between -3 and 3, but we're not actually including -3 and 3. So the way we could show that graphically, and so this is definitely something you should have seen in maybe even a pre-algebra class, but definitely in Algebra 1 and Algebra 2. So we represent the less than symbols with an open circle because we're showing that we are not including -3 and 3 in our solution set or whatever it is we're trying to represent. So with interval notation, basically interval notation is a shorthand version to not have to write out this inequality. So the interval notation, you take your lower number, which was -3, and we have a parentheses on it. Basically, that's telling everybody that -3 was not actually included in the set, but it was the lower end of our interval, and then comma, kind of like you would in a point, and then 3 is our upper end of that interval, but also with a parentheses, because 3 is also not included. So this interval notation, the parentheses, -3, comma, 3 parentheses, is a shorthand version of how to write this inequality. We could also use the parentheses on our graph instead of using open circles. So you'll see in the homework or maybe in our textbook at some point, you might see it represented that way. We just need to remember basically the parentheses is representing an open circle, which is representing just a later than, less than or greater than symbols. Therefore, we're not including those numbers. That's the key. is that -3 and 3 are not included in this solution set. Now let's compare that to when we do have the less than or equal to symbols in there. So this one's, again, very similar looking, except it says -3 less than or equal to x less than or equal to 3. So in this case, they would be closed circles because we are including those numbers. They are part of the answer set. So the way we represent that with interval notation is with brackets. So brackets are our way of saying we do include that number. So -3 is part of the solution set, and +3 is part of the solution set, and all the real numbers in between. Compare that to example 1. Again, 1 was just saying all the numbers between -3 and 3, but not actually including them. And just like before, instead of using closed circles on the graph, we can also use the bracket symbols. The idea is for you just to remember that brackets are meaning that we are including that number in our solution set. Now, you may have a compound inequality where it is like one of each, and that's definitely a possibility. So in this particular situation, -3 is included, but +3 is not. So when we're trying to list all of our numbers that would be included in this solution set, -3 is included. It'd be part of our solution set, and then it would include all the numbers all the way up to +3, but not actually including +3. So we would just have a mixed symbol in our notation. So bracket on the -3 side because it is included, parentheses on the +3 side because it was not. And again, we can see that from the symbols in the original notation. And then, of course, you could have it reverse the other way, where it's a lower number that is not included and the higher number that is included. So it's totally fair game to have bracket and parentheses mixed in any order in your problem. All right, so this next little box is just a quick little kind of review of what we've talked about so far, but I do want to make sure you heed this caution. When you're writing interval notation, you have to make sure the smaller number is always on the left-hand side, and the greater value is on the right-hand side. And that is a construct that you will have to make sure you are following. Okay, so these were all compound inequalities, but what do we do if it's just, going on and on forever? There is no ending point. So kind of like the first few examples I gave with x being greater than 2 or greater than or equal to 2. So those, such as this case, would just keep going on and on forever. So this says x is greater than or equal to 3. So you can see from the picture, 3 is our lower end number. And then it just keeps going on and on forever. We have this arrow here saying it's just going to keep going. Any number greater than 3 and including 3 is part of the solution set. So we need to be able to tell everybody that it keeps going on and on until infinity. It just keeps going bigger and bigger and bigger. One thing you need to be careful of when you are needing to use infinity in your notation, infinity always gets a parentheses. You can't ever actually reach the number infinity. There's always a number bigger than it, and so you can't actually ever reach it. So it doesn't get a bracket because a bracket means it's actually included and you can obtain that number. Infinity we can't actually ever obtain, so we just use a parentheses on any time we're using infinity. Okay, and so they don't do a great example of these bottom two here in this interval notation, so I want to just do a quick example. So say we had x is less than, let's just do less than, x is less than 4 or something. Okay, so if we had that, so here's our number line. We have 0, 1, 2, 3, 4, -1, -2, something like that. Okay, so if that's our interval, or our inequality is x is less than 4, to graph that, we would go to 4, we'd have an open circle, and we'd graph everything less than 4. That's exactly what it tells us to graph and highlight. Okay, so in this case, this end is representing negative infinity, right? Going to the right-hand side would be positive infinity. Left-hand side is negative infinity. And so that would definitely be our lower end number. So we would have negative infinity, parentheses, because there's always a parentheses on infinity. And then the upper end number would be 4. Now in this case, it would also get a parentheses because 4 was not included. It was just a less than symbol. Okay, and I was totally wrong because there is an example, basically exactly what I just did, just using 3 instead. But practicing using negative infinity. Okay, so we're going to do this next example, example number 6. We're going to do that on your notes paper. So this is where you need to have out your notes paper, and we're going to kind of fill in a chart. All right, so on your paper, go ahead and jot down the example. You can call it example 6 or example 1, doesn't really matter. But then label this top line of the chart. So we want the inequality notation. So we'll be able to take what's here in words and write it as an inequality. And then next to that, we're going to do graphical notation. Leave yourself some space for that, like a decent amount of space. Then interval notation, and then type of interval. So I'll give you a quick second to get that written down. All right, so example A, or problem A, says between -3 and 3, not including the endpoints. So we're going to do the graphical representation first. So we're going to draw a little number line. All right, and then on your number lines, you always have to make sure you're labeling where 0 is. So make sure that's always something you label. And then we want 3, so 1, 2, 3. You don't have to label every single hash mark, but the key numbers, make sure you're including those. Okay, so for the first one, again, it's between -3 and 3, not including the endpoint. So it means not including 3 and -3. So those are going to be open circles. And it says between -3 and 3. So we're going to include the area between those two. All right, so the inequality notation would be -3 less than, not equal to, just less than, because we're not including it, x less than 3. Okay, so that takes a while. People tend to get confused. They don't know what inequality symbol to put in there. It gets all messy. So what's easier to use when you're having to write it yourself is interval notation. So again, we're going to use a parentheses with -3 because -3 was our lower boundary. Parentheses because it's not included. And then our upper boundary is +3. Still a parentheses because it's still not included. All right, and then our type of interval, this is called an open interval because we had open circles. Again, open meaning we did not include the endpoints that were there. Right, and so that's the kind of basic idea. This is basically what your first homework problem is going to look like. So they're going to give you descriptions, and they're going to want you to be able to complete these 4 categories. So I think it's easiest to do the graph first because then you have that to work from. Okay. All right, so question B is worded poorly. So I'm going to say what it is they were trying to do. So the part they're missing, because I've seen the answer key, what they're wanting to have here. What the part they're missing is it should say, write the set of numbers, write the set of numbers that are, and then it should still say between -3 and 3. And then comma, including -3, but excluding +3. So it was just poorly written, but that's what they meant. So this little piece here should also be there. It's just a poorly written thing, but that's what they're saying. So between -3 and 3, comma, including -3, comma, but excluding +3. Okay. So first thing I want to do is draw a graph. So again, you need to always label where 0 is. 1, 2, 3, 1, 2, 3, -3. Okay, and then whatever endpoints it is you are working with for that problem. Okay, you don't have to label every single hash mark along the way. So including -3 means we have a closed circle or a bracket. Excluding +3 means it's still an open circle or a parentheses. So inequality notation would be -3 less than or equal to x less than 3. But the interval notation, what we're, oh, sorry, I forgot to graph the in-between part. So between those two numbers. So again, basically we're saying from -3 all the way up to +3, but not actually including +3. Like +3 is not on the actual list of answers. So in notation wise, interval notation, we'd use a bracket for -3 because it was included, but a parentheses on +3 because it was not included. All right, and then our interval type is considered to be half open, comma, half closed, because that's what we have. We have one open circle, one closed circle. So one of our endpoints was included and one was not. Okay. So question C says, do this, write the set of numbers that are, C says, greater than or equal to 3. So again, we're going to label 0, 1, 2, 3. So the numbers that are greater than or equal to. So that's the key to tell me that it's a solid circle. Greater than is telling me to head this direction, but it's going to go on and on forever. So you have to highlight the arrow, show that it's going on and on forever. So inequality notation would just be x is greater than or equal to 3. Interval notation, we'd have a bracket and then +3, because that's actually my lower number, my lower end boundary on this problem. And then I would say it goes all the way to infinity. But remember, infinity always gets a parentheses on it. Okay, and so then the type of interval we have is considered to be infinite. It doesn't matter that the 3 was closed even if it had been an open circle. So like maybe if 3 had been excluded, and still be considered an infinite interval because it does go all the way to infinity. Okay, so we've done, just kind of cross off the ones we've done to keep it straight. A, B, and C. So now we're up to D. So again, we want to write the set of numbers that are less than 3. Again, label 0, 1, 2, 3. So less than 3 means I'm not including it because it's not less than or equal to 3. So it's an open circle. And we're going to go less than. So x is less than 3. So that's how we would write that in inequality notation. In interval notation, the lower end is actually negative infinity. And then the higher end is positive 3. But it gets a parentheses even on the 3 this time because it was not included. It was just less than 3, not less than or equal to 3. And again, this is considered an infinite interval. Okay, so we didn't care whether it had the bracket or not. It's just considered an infinite interval. Okay, E. E says write the set of numbers that are between -3 and 3, including the endpoints. All right, so we have 0, 2, 3, 1, 2, -3. Okay, but this time what's different is we are including the endpoints. So they're both going to have a solid circle. So we want the numbers between them, but they both end up with a solid circle. So the compound way to write that as an inequality would be -3 less than or equal to x less than or equal to 3. And again, a lot of times with these compound inequalities, people get stuck with which inequality to end up using. And so that's where the beauty of interval notation comes in. You don't have to get stuck on that. So we know -3 gets a bracket because it was included. And then we know +3 is going to get a bracket because it was also included. And then our type of interval is closed because both ends were closed. So notice on A it was considered open because they're both open. E is considered closed because they're both closed. B is a half and half, one of each. All right, and then F, all real numbers. So basically, here's our number line. All real numbers would mean everything. From -infinity to +infinity. So you say -infinity less than x less than +infinity, or -infinity to +infinity. Again, both infinities have just parentheses on them because that's what we always put on an infinity because it's not included. You can't ever actually obtain that number. Right, and then it's an infinite interval because infinity was included. Or infinity was part of our solution set. Okay, so that's the basic idea. So being able to take the description and fill in these 4 categories, that's what we're looking for on practice problem number 1. So like I said, the first part of that worksheet will all be in your notes. It's there for you to review as you need. But then at the bottom of the notes is where the practice problems are. So you do need to scroll through all of those notes I went over with you, read them again, and then work on these practice problems. So you can just do them on a separate sheet of paper. You do not have to print it off of Canvas or anything like that. So question 1 has A, B, C, D, E. They want you to fill in to a table, kind of like that blank table, exactly like what we just did on the last example. And then question number 2, they've given you 6 graphs. They want you to be able to write the interval notation that would be represented by that graph. And then 3 is going the other direction. They've given you the interval notation. They want you to be able to create the graph that goes with that. And then question 4 is like an error analysis. So Missy gave her answer, but her teacher marked it wrong. Explain why. And then the answer key is not on the next page. That's the bottom of what you have. The answer key I will make as a separate page in Canvas for you to go look at after you have completed these practice problems. Do remember that these problems will be on our Chapter 1 test. And so you do want to make sure that you are getting through the practice problems and asking for help if you are stuck on anything. All right, guys, let me know if you have any questions, and I will hopefully talk to you soon. Bye.